Hello, Yannic.
Hi,
This is
nice to
this is
see you.
unreal. So today I'm hosting Yannic. He is the host of ML News, which is literally my favorite series on YouTube, to be honest. He's also doing paper reviews, which I think are very valuable. And he's also hosting Machine Learning Street Talk. He has a PhD, papers on various topics, and he's the CTO of DeepJudge. That's how I would describe you, but can you also describe yourself, like introduce yourself in your own words?
This was already very nice. Thank you. Yeah, it's great to be here. Thanks for the flattering words. I don't know how I would describe myself. Yeah, I've recently finished the PhD here at ETH Zurich, which is the Swiss Federal Technical University, and my research areas were sort of core deep learning. When I started, deep learning was sort of just becoming a thing here around 2015, 2016. And, we started with like 2 GPUs, and that was already like, whoa, we have 2 GPUs, right? For the whole lab. And, we took it from there. So I naturally lived through the deep learning revolution a little bit. And so I was exposed to all of these kinds of things, and I had a broad interest in all kinds of various areas of machine learning. And then someday I decided to record some videos for YouTube and explain the papers that I've read, and that sort of became a thing. So now I'm best known, I guess, as a YouTuber. Yeah, though, as you said, I do have a day job, but
So when I dived deep in your Google Scholar, I saw that you have works in various domains, which is very impressive. I wanted to ask you about your main research interests. I don't know if it's a thing for you. That is probably not given your, Google Scholar. How do you keep up with these domains?
So my main interest, I started off in optimization. So I did
Like
a
what?
master thesis on convex optimization. So
Mine
stochastic.
was too,
Yeah,
by the way. It was my
cool.
bachelor's thesis, yeah.
That's how a lot of people get into machine, or at least got into machine learning, right? But then
Yeah.
I switched over to yeah, I started, and then very soon after came the GAN revolution. Sort of everyone was doing GANs. I remember walking around at like NeurIPS in one year, and every single talk I walked past was about some sort of a GAN doing something. It was crazy. So naturally, I also jumped on the hype and sort of tried to publish some papers in GANs. Eventually, then I transitioned to more of the adversarial examples aspect of that, and that finally was what I did for the rest of the PhD. So mainly works in robustness, adversarial examples, some GAN related things, and some NLP related things, which I did together with Google Research.
Yeah, I saw a few of your papers one was on BERT and the other one was on search engine optimization somehow with agents. So you're also working on reinforcement learning or like decision systems?
Yeah, that the paper I think was just released last week or
Yeah.
so, but it started a long time ago. We have this agreement, our university, with Google Research, which is really cool, which is where PhD students can essentially be a consultant at Google and work with their teams on research projects. So the goal there was to create an agent that would search for you. So whenever you have a question to answer, you might go to Google and you type in a few keywords and so on, and then you see the results and you realize it's not exactly what I want. So you reformulate a little bit, you might even use these operators, right? Like the minus. I don't want this particular word. I want this other word, and the quotation marks. So the goal was to essentially create an agent that would do that for you, and that would go to Google or to another search engine and do these iterative searching for you. And we have some results there using either trained like language models or reinforcement learning. It's not super good yet, but I think it's a cool way to go about it.
That looks like a different approach. I don't remember seeing such thing previously. Maybe there is, but yeah. Can you tell us about a bit in the paradigm of machine learning research, and like there are types of papers and you evaluate them a lot. Can you just tell us about the paradigm a bit?
I'm not sure what you mean.
Like there are various trends and hypes in machine learning research, and like how do you pick the papers and how do you evaluate them?
Yeah, I mean, definitely there are various threads, right? So there is always what I would say like the hype topics of the day, and these make up they make up a lot of papers, but they also make up most of the attention of people drawn to them. To me, how I select papers is mostly what I find interesting, and that is sometimes inside of the hype, but sometimes it's also outside of the hype. To me, I've never gone by anything else than what I'm interested in, and I never saw myself as sort of a neutral selector of good work or something like this. So I don't want to become that by any means.
Yeah, I guess it's just what is your there is a lot of papers on arXiv, and they are just there's just a lot, and it's probably hard to pick. So you from what I get, you pick them either from trends or you pick them because you think that they are good. What is your mechanism and how do you evaluate them? Do you also reproduce them while evaluating them?
I have reproduced only very few, where it was really easy and straightforward, and I knew what to do, and I was pretty sure what the result was going to be. I think on one of the dimpled manifold hypothesis, which was a paper in the topic of adversarial examples, and they made some claims. And being in this field, I sort of knew exactly what I had to do and how long it would about take, right? So, but other than that, I don't usually reproduce anything. Whenever I think experiments are shaky, I'll just say it, right? But as to selection, this has become a problem, I think, for everyone in the field. There's just too much to read. When I started the PhD, I read all of arXiv. Every morning, I had a little script that would download all the new papers from like the various lists I was subscribed to, like CL and LG and the kind of ML arXiv lists. But it's just become unbearable. So now I guess everyone has to rely on automatic filters, on sort of systems like arXiv Sanity, on Reddit, on Twitter, on people posting on Discord, or this paper or that paper. I have to say it has become a problem. The importance of things like clickbait in titles has increased dramatically. I'm not sure if that's good or bad, but it's often more important that your title is really on point and your first page has like a nice figure on it or something like this, rather than the work quality is really good. So it's become a bit like YouTube, I guess.
Yeah. The other day I saw this tweet where someone reached out to the researcher, the author of the paper, to saying, I couldn't reproduce your paper, and the author basically said, you have to do hyperparameter search and set the seed to X. And I was quite surprised.
Yeah. Well, that's life, of course. Usually you just say you did it wrong, right? Usually you just like, well, you did it wrong. You did it wrong. Yeah. It works for me.
On you. So like whenever I watch your videos and your comments, and I really like, your spicy comments on ML news, I really love it. I feel like you're on the axis of, from Geoffrey Hinton to Gary Marcus, you're more Geoffrey Hinton. But this is what I guess. Like, how do you perceive the status of machine learning in general, given that there are so many papers out there and the work, and there are so many questions? What do you think of the capabilities and the incapabilities of machine learning, and what could have done better?
Yeah, I think there is. Yeah, it's a hard question, right? I think there's this trend that we are observing right now that we know if we make our models bigger and feed them with more data and let them train for longer, they will become more powerful in whatever way you make that, right? And so I agree with people like Gary Marcus that, they come in every time and they're like, well, it still doesn't understand anything. Let's say a language model, right? It still doesn't understand anything, or a visual model that just selects a class. It still doesn't really get what's on a picture and so on. On the other hand, you also have to admit that these things are becoming increasingly powerful. And at some point, well, there are two questions. At some point, does it matter whether or not it understands anything if it reliably does the task you ask it to do? And on the other hand, you may also ask yourself, well, do humans really qualitatively understand things differently, or is it just like a trick that your mind plays on you because you've been exposed to so much data? So I think you do get into maybe even into the philosophical at that point, though I do choose rather to be, I say, mildly optimistic and excited by the progress that machine learning is making, rather than always come in and be like, well, it still doesn't understand anything, right? Yeah.
Yeah, I recently started as a developer advocate, but I've been doing machine learning engineering for like 2 years. And I've been working with language models mostly because I was doing NLP tools, chatbot development and stuff. And I feel like they actually work. Like they work really nice on most of the domains, like semantic similarity. Like it's a very easy approach. It's not like complex cognitive kind of model as on that axis, but they do work nice in industry, in my opinion. So I completely agree. And whenever I see those people saying like, does it understand, I feel like it's a more philosophical question, because that also depends on how we understand things. Like since I started doing machine learning, for like 4 years I've been doing it, I question my understanding of things as well. I'm like, do I overfit? Am I really understanding what is going on? And
I mean, there is a point, right? There is a point to be made that humans can still, we all pretty much agree that the capability of abstracting knowledge, of abstracting the things we work with, is probably yet not achievable by these machines, at least in the way that we do it. So we see something for very few times, we abstract something from it, and then we're able to take that abstraction and apply it in various other ways and so on. There is obviously things that are yet, let's say, out of reach for these machines. And that also comes to the types of mistakes these machines make, right? It's like, of course, GPT-3 is going to tell you, of course, GPT-3 is going to tell you to, like, I don't know, drink poison or something like this, because, right? So I think, there also needs to be an adjustment a little bit of the users of these systems to understand, look, this isn't a competent human. This is a statistical machine, right? That is just outputting sort of the patterns it often sees, even though those may be really powerful, but still, right? This does not have an insight in what it's, in the finiteness of life, or the tragedy of losing someone loved, or anything like this. So I think, there might also be a little bit of a shift in understanding of the people that use these systems. And by the way, congratulations on your new job. I've seen that. It's really cool.
Thank you so much. I also, can understand the other side, because some of the models are actually presented as over capable and very understanding, and they were even presented and marketed as this is going to take your job, and so I can also understand the other side, because there is an incredible hype and it is marketed by some people also, giving very short deadlines in major stuff like AGI. And I also can understand the other side. Like I also watched your ML news like 3 weeks ago or something. And there was this comment on, Tesla AI Day, someone was dancing in a costume and you were really enjoying, how people got pissed off of, people getting like, no, this is not going to happen in the near future. Like, I'm also like sometimes one of those people, but like I try to, calm myself down and try not to explain to people that this is not going to happen in the near future.
Yeah, I mean, with that particular thing, you really never know whether they just do it, whether they just want to get a reaction. Like if I was in that position, that would be something that I might do, right? To just be like, let's just, it's already a meme that Elon Musk already promises things always in 2 years or so that are never achievable. It's already a meme, so let's just like overdo it completely. I'm not I'm not sure, but yeah.
Or maybe this is just to calm down a few investors. Who knows? You will probably get to know it, because
Absolutely.
you are also a CTO in DeepJudge. Like, can you tell us about your work over there?
Yeah, I like, we face the same problems, right? You're trying to communicate to people who aren't even necessarily in the digital business, so that they're not in the information processing business, how what these new technologies are doing is different qualitatively from maybe, what the features of Microsoft Word or kind of like old text processing tools. So you're trying to communicate this without without going all technical and be like, well, but we do language modeling, which means we factorize the distribution of language according, like, so it's natural to say something like, we are trying to get these models to understand the meaning of a piece of text. And yes, of course, I see that you jump in. It's like these models, they don't really understand anything. But in a first approximate, and you have to usually you have to follow that up with more clarification of what is possible, what is not possible, because I also think it's bad business to oversell, right? Because at the end of the day, you deliver something. If people aren't happy, you don't have a sustainable business. So you have to be accurate in what you promise. But in a first approximation, like you have to communicate somehow what's different and good about new technology. So we're in a similar trap here, I would say. So my work at the startup. So this is a startup that I founded together with 3 other PhDs from here, from the lab. We have various experience in machine learning and NLP and so on. And I'm the CTO. So naturally, given that we're all machine learners, I'm not doing super much machine learning myself anymore. So I'm doing everything else. I code, I do DevOps, I do databases, I do scraping, all this. Yeah, I mean,
stuff.
Yeah, I interview people, front end, APIs. It's fun because I like to build things naturally. I still get to do quite a bit of machine learning, but I've also enjoyed quite a bit learning about everything around the machine learning that really needs to go into a product. And I think it's a valuable experience.
Can you talk about what you are actually building and
Sure. Yeah, I mean, it's ultimately not too. I mean, we are in the legal tech world, so we're essentially trying to take the last 3 years or so of NLP from research. What I think we're quite well positioned to do, and apply this to the legal domain, starting in Switzerland, but we're really focusing on Europe and then also the international market. And the legal world, it has a few unique challenges, a few unique data types, and so on, which means that you cannot just straightforwardly apply the regular techniques. So you have to be a bit careful, understand what's going on in the law and so on. And
you need domain expertise like any other data science problem.
You do absolutely. You need domain expertise, and you need that's essentially it. You need to talk to your customers well and so on. So ultimately, I don't think it's too, let's say, it's not very out there, as we're trying to essentially bring the successes of academia into products that will help people here. But I do think that most people that could deliver what we deliver, they go to Google or so. So I do think we do face quite little competition, at least here locally.
Is it some form of automating paperwork in legal? Because as far as I know, that's what state of the art does, but I don't know about the rest because they are too futuristic.
Yes, it's so we're trying to build sort of a common core text understanding pipeline, and then really adjust that to the customer's needs. So yes, it's absolutely about automating paperwork, but also not necessarily automating, but supporting in various domains like research, e-discovery, due diligence, contract analysis, and so on. Though in some places there are already competitors that are quite specialized. So we're trying to fill out all the spaces where there isn't a good solution yet.
I know a company doing this, by the way. It's called Primer. Then my boyfriend works there, and they are like doing legal stuff. They're
Nice.
also doing other stuff as well to some companies. But I don't know if they do it like yours, because yours is very specific. It's more like what they do, as far as I get, is more like document classification and stuff.
I mean, there is a lot of action. I don't want to say there's no competition. There's actually a lot of a lot of startups in the legal tech space. We're trying to carve out our niche where we think we're really good at, which is sort of the ML part, the machine learning part, the deep learning part, and we're not trying to compete in areas where we are no better than anyone else. Yeah.
But do you think, people usually make futuristic predictions on, legal stuff? Do you think you are going to be there? Stuff like that you can see in sci-fi movies and such. Some robot judges or advocates and stuff. That's a too happy question, but I just
sure,
wanted to
yeah.
ask you.
Sure. I mean, we're not going to replace any lawyers or judges. Like, law. Surprisingly, it is kind of algorithmic in that, that especially the way legal scholars work with the law, it's quite algorithmic, right? It's like, okay, like here's a law, here are clearly the preconditions, here are the consequences, and so on. So it feels very much like an algorithm, but then very, very often in the law there is a value judgment somewhere. So in most of these questions, you have to make value judgment. There is often a standard of reasonableness. There is or various other standards, like, well, but for causation and things like this. And a lot of these are really not really subjective, but they are value judgments. And sure, you can say, well, we go about it statistically and we model the reasonable human and so on. But I don't think that will replace the value judgment part of the legal scholarship very soon. What we can improve is definitely the tedious parts, where the collection of information or the clustering of information, or going through a lot of documents and searching for very specific things, highlighting specific things, anonymizing things. All of this is things that you can tackle without having to resort to futurism.
That's also how I perceive machine learning as well, because I basically think that it should be assistive in some way and automate boring tasks and let the people actually do the quality work. And, putting this in law is actually, putting the further part in the law is actually a very ethical and philosophical discussion. Like, it's open to those kind of discussions. And yeah, that's exciting though, like actually automating things. I've seen, like computer vision people doing this, but I don't like it when people say, like, do not study radiology. You probably know who said it. But it's too much. It's just too much. Like, you can simply make the life of a doctor easier by automating the hard work, like put it in a box or something and then just give it to them. But it still requires supervision. I mean, I don't believe in those futuristic stuff. In case if anyone wants to talk about it in the audition, in the audience, sorry, I just wanted to ask you about that. It's not like I am on that side or
sure.
I'm mostly against the hype, so
I mean, you can, like, I don't know, I always felt YouTube is a place for having opinions, no matter what. It leads to more interesting places if you're willing to just start out with any position that might even be a little bit extreme, and then you can still talk about it. But.
So I can't spell this name. Is it Michael or Michelle? Ask him if he sleeps in his sunglasses. I saw your photo with no sunglasses, and I felt like I was too much invading your private life or something.
They do come off sometimes. I'm still not sure if it was a good branding strategy, because, well, it's dumb to code with these on, because now I have to up the brightness, right? And then it's still kind of dark, and then they're polarized. So if I do this, I don't see anything. And yeah, well, but it is what it is now. Brand is brand.
So Stefan is one of my friends. Do you know Stefan Schwetter? He's actually working for the DBMDS. It's Deutsche Bibliothek. He's doing most of the BERT models online,
Cool.
like most of them.
Nice.
So yeah, I want to ask you a question for myself, actually. Like, how do you plan your research? I'm currently doing my master's, and I'm struggling my way through this specific NLP paper, and I'm trying to write it. And I have recently started the literature review, but I still couldn't start it. Are you good at planning your time? Because you are like writing papers, doing YouTube, doing this development work at DeepJudge as a CTO. Like, how do you plan your time?
I'm terrible at planning my time. I do everything last second. I procrastinate things. I forget things if I don't write them down. I'm very, very, very terrible. So I can give negative advice. I mean, that's what I can that's what I can do. But like, I think there's not too much of a secret at it. The good researchers, which again, I don't consider myself a good academic, but from my experience, good academic develop a little bit of a taste of what is sort of the unit of work that is, let's say, publishable, and then they just strive to achieve that. So they identify some open problem, and a thorough literature review is like a really good thing to do there. And then I think the good people, they identify like one unit of work they can do. So not like, an open question, not like, I'm just gonna do something, which is what I did. But they identify like a clear goal as well, and they say, okay, if I reach that, I think that will be good for one paper, right? And then they invest a lot of time into first writing this up nicely. I think in order, a lot of people who do get published, often they spend quite a bit of time. Either they have lots of skill, or they spend quite a bit of time just writing up the paper in a nice way, and then make sure that there are no like obvious criticisms. And that might mean that you need to do some ablation experiments, or some experiments on other data sets, or that might mean that you need to, whatever it needs to be, make sure that there are no obvious points where someone can criticize your paper, because that's exactly what reviewers nowadays tend to do. They're essentially going through your paper, and if they don't instantly like it, they're going to look for reasons to reject it. And so I think you should not give them any of these reasons.
Yeah, that's really good advice. I'm just a master's student, by the way, and I have started this lab in my school, and I'm quite intimidated. I don't know what to do, but I guess I will just get used to it.
Yeah, I mean, for writing papers, I think if you start out, it's just worth reading a lot of papers, like just the papers that do similar things. Then you just read them, emulate their style, maybe before you are really into it, it's probably good to just emulate the style of papers that have been published before. Naturally, will lead you to do good experiments and so on. And then with respect of planning your time, I don't know, like you'll have to do that yourself. I have no idea how to do that. Yeah, as I said, I'm terrible.
By the way, how do you reproduce papers? Because I've seen you doing that, especially the last time it was Apple's CSAM one, I guess. Like, what is your process? Like, if there is no code, if there is code, if there is data set available, how does it work?
Yeah, I mean, if there's code, it's quite simple, right? Then it's mostly about changing something. But other than that, it really depends on the paper. Sometimes the papers describe very accurately what you need to do. Sometimes, very often, they don't. And then, what can you do? You can the best you can do is implement what they claim they've done, and then guess which of the tricks that they have used, right? Because there are some standard tricks, let's say data augmentation, or maybe some sort of regularization, like weight decay, that you might try out. Maybe they don't mention an optimizer, so you have to guess what optimizer to use. And I've seen a lot of people waste a lot of time trying to reproduce papers. And for one or another reason, I don't think I've ever seen anyone really successfully reproduce a paper if there's no code available. Because it's just hard, right? It's hard from like a textual description to really get everything right. So if you really need to reproduce a baseline, I would say do as best as you can, and then just take the trend, right? So if you do data augmentation, do it in the baseline. If you don't do weight decay, don't do it in the baseline. And then, to me, that's good enough. I don't need the exact same number that the baseline reached, right? And then you can write it up like this. But I think it's almost always how should I say, like, it's not really fruitful to try to reproduce a paper and get the exact same result, because it's probably not going to be successful.
Seriously, until now, I thought that people were just implementing it with no code from the figures and the layers in the figure and stuff. And I thought people were that good. I guess, and reviewers were actually turning down based on that. So that was quite a realization, actually.
Well, reviewers sometimes have code available that you might not have in public, right? There's options to submit code along with your paper, and then it's not necessary that you also publish that code at the end. So there are ways, but no, I don't think I've never read a review that said, I've reproduced this and I didn't manage. Reviewers don't spend that much time on a paper. And even some papers, when they compare to baselines, they often just take the number that baseline has achieved, like that they report in the paper. It's a way to do it, especially if there is a standard benchmark. Yeah, sure, they can fake it, but yeah.
So they're asking if you have any hot takes on foundation models. Though I watched your video, and if you have some.
Well, hot takes. I'm not sure. So I think a lot of people are criticizing the fact that they're, called foundation models, saying, well, they're not really foundations. They are, they're what we said before. They don't really understand things. They're not good as a foundation. I'm like, well, I criticized the report more, first of all, for having like 115 authors, which not all of, right, it's not a problem to have many authors, but by their self-admission, only like subsets of authors authored subsets of the paper. And to me, that's not one paper with 115 authors, because in that case, every author should take responsibility for all of the paper. It's like 20 papers, each with 5 authors or so, right? That there's a bit of a, and you can see how this paper is going to be cited a lot, right? So now 115 people each get a citation every time, not necessarily their part is cited, what they've worked on, but something else. So they get the credit, but whenever someone criticizes a part, they're going to be like, well, that's not my part, right? This other person wrote that
makes
part.
so much sense.
Sure. So that's kind of, it's, but the more problem is that I think it's just a culture hype, just because it's like hip to complain about these models and the fact that, we don't have access to them and so on, because from the way they define foundation models, it's not at all clear that they're talking about these models. Like, they define foundation model, a model trained on at large scale on broad data, and then adapted or fine-tuned to downstream tasks. And like,
that's a pre-trained model, actually.
Well, first of all, it's a pre-trained model, but second of all, there are models that fit the definition much better than GPT-3. And I made the example of like ResNet 50, which is trained on broad data on ImageNet at large scale, right? Like, large scale, is it really different because 3 years ago it meant something different? No. So ResNet 50 is like the ultimate super duper foundation model, and none or almost or very little of the arguments they make apply, and it's not mentioned anywhere in the report. So it's clear they have set their mind on complaining about GPT-3, because frankly, there's a lot to complain about, right? And about BERT and these language models. And then they have worked backwards and made up some sort of a definition, some sort of a broad sounding definition to start off their paper saying, well, there are foundation models, rather than saying, we want to complain about GPT-3. This is, to me, like, this is how the paper came to be in my mind. Otherwise, the content of the paper would be different. And that's a little bit of the issue I had. And I made the example of, it's like me writing a paper on complaining about like abelian groups from group theory, and then writing, but the rest of the paper complains about GPT-3, because somewhere in GPT-3, I'm sure an abelian group is used because I add things or something like this. So yeah, it's a bit of a rant.
Complain about it, I guess. Yeah. Also, Burton ResNet, as you said, is more of a foundation model than GPT-3, because also GPT-2, because one is zero shot and other one is few shot, and that isn't considered as fine tuning.
But they claim they phrase it as adapting, right? So that they bring in GPT, and they do complain about BERT quite a bit. But so they complain about BERT, GPT-3, and I think they have one more example, but yeah, DALL-E. Yeah.
I mean, yeah, I guess adapting sounds right. It's just the reason why GPT-3 came was because that you don't have to fine tune, and you just need to give few examples. So if that's the case, I cannot object to that. I don't know how they complained about BERT though, because it's mostly an understanding model. You can actually make it face the client more than generative models. Like I didn't read that part on how they complained about the
Yeah,
BERT, but
I mean,
BERT is
yeah.
nice.
Well, I mean, they of course they do have a point, right? In that if I build a single model from a lot of data, right, that might cost a lot of money to train. No, not anymore, right? It can train BERT or like an ImageNet model for a few dollars now, but the development has cost considerably. And then everyone just starts from this one checkpoint, even for fine tuning. Then it does matter what the one checkpoint is, right? If that one checkpoint has like blind spots for certain areas of language, then most of the models that are derived from this will inherit that blind spot, right? Like this is, I'm not criticizing this part of, right, if there's a security flaw in this one checkpoint, the models downstream will inherit that. If someone has poisoned the training set, this will, like, the danger of centralization when we do pre-training and then fine-tuning, and everyone just starts from the same step for fine-tuning. The dangers are absolutely there. I'm not trying to deny this, but yeah, it just seems it seems like, yeah, what I've said, and plus it's a bit of a name grab, right? Like it's it's now everyone writing a paper about this has to essentially cite them.
Yeah. But I guess I just like these models, at least the ones that are open to everyone, is because it contributes to democratization in some way. Like people don't have to start training from scratch and don't have to train their models with this. I'm sorry if a noise comes up.
That's okay.
So yeah, it contributes to democratization in this way that you don't need gigantic amount of data to train your model, teach it the language itself from the scratch.
Mhm.
You just need to fine-tune on the downstream tasks. So that's why I'm actually against the models that are not open to everyone, and because it's like the opposite direction of democratization, like, and I basically fear if it ever becomes a trend. I don't know if it became a trend. After GPT-3, they have trained this switch transformer, Google did, and
Yeah.
they didn't release it to anywhere, and it was even larger than GPT-3. It
Yeah.
was, I don't know, trillion.
It's like a trillion, yeah, but
Yeah.
mixture, but sparse. So there's a debate about which one really
Yeah.
has actively more parameters. But I mean, there's a lot to be said about this. Like I generally don't have a problem with companies saying, we're going to invest millions of dollars into training one of these things, and then we're not just going to give it to you. Like you're going to have to pay in order to you. I don't necessarily have a problem with that. There is some danger of centralization if only one company does it, but I don't have a I do have a problem if a company says, we are here to democratize it. We want to be open, and we want, our goal is for all of humanity to benefit from and then they do something like this, right? I'm more disturbed
Yeah,
by,
I guess that's a bit.
yeah, the hypocrisy behind this. Then I'd be completely fine if they say, look, we've invested a lot of money in order to make money. Now we want to make money, right? Cool. And we don't have, like, let's not, the reason why, for example, nowadays I can train a BERT model for so few dollars is because Google has done it first. And the development of BERT has cost Google millions because they had to try out a lot of things, right? They had to, even understanding their new TPU hardware that was done in the course of developing BERT. This masked language model objective didn't just fall out of the sky. I'm sure they've tried loads and loads of stuff, and they didn't have the most efficient primitives yet, and so on. So the reason why I have the ease of pre-training even my own BERT now is because one of these big companies has put in that many resources. And the same with GPT-3. Like now we have Eleuther AI trained whatever GPT-J, and we have this Jurassic 1 model, right? And lots of these
AI
big companies,
Fancy One.
yeah, they're training their own models. And the reason why they're doing that is because OpenAI has made GPT-3, has shown, look, this is something really cool. You can make money with it, and then others come in. So it has good and it has good and bad sides. I wouldn't necessarily doom it, altogether. Though I will make the occasional joke about OpenAI not being open.
Yeah, open. It's just I actually feared about it. I was feared about it because I mean, this is going to make companies like Microsoft a monopoly, and not so many people will get to have a say. And what if they make a new architecture that is closed? And what if other companies decide that we are going to release all of our architectures as closed, and this is how this is our policy on pre-trained models now, and deal with it.
Yeah.
This like inverse democratization somehow.
Sure. I mean, yeah, I'm as I said, there is definitely a danger of centralization, but I think if there's a way to, so we've seen the same things, right, with like open source software, and there are ways to make money while at the same time being open source in software development. And I think there's got to be ways to make money with these large language models while at the same time releasing them. I mean, Hugging Face is a nice example for a company that does make money, but I can download all of their models. So yeah, I think right now there's still enough players in the market that I think it's going to go reasonably well forward.
Yeah, in Hugging Face there are closed, solutions for the enterprise, and there is one for developers, and it's actually great because they have actually started from as a community, not like, we are as a company monetizing everything, and we are going to have this community. They have started as a community, and that's why I was so impressed by them and actually decided to join them, I guess. So people have written some messages. They respect you a lot. They say the legend is here. Stuff like that. I don't know if you can see them. But I don't think we have any more questions except for the rhetorical ones that are meant as a joke and a sarcastic way. So yeah, thank you so much for coming.
Yeah. If you're here and if you are subscribed, thank you so much. If you've seen that our channel has just passed 100,000 subscribers today, so I'm pretty happy about this, and my greatest thanks to everyone who watches or listens or anything like this. I wouldn't have not guessed this. Like no way ever I would have guessed that, in the world of YouTube, where the attention span of people is like 12 seconds, that someone would sit down for 45 minutes and listen to a paper explanation. I did not think that would happen. So I'm very grateful to everyone who listens and watches.
It's actually quite very valuable work. There is so many hype out there for the beginner ones. Abhishek, right? Abhishek has put this once in words. Like if I were to just shoot how to start in a data science video, I would get thousands of reviews. But yeah, here is a video on byte pair embeddings.
Sure, and it's valuable, right? There is a pyramid here as well. Most of the people are interested or beginners and so on, and there needs to be enough good content for them. But we also need content for people who are more advanced and people who just want to keep up with maybe academia because they're now working in some job. So yeah, I mean it needs the whole from up to down.
I'm actually quite inspired by you. I have this Twitch channel in which I teach what I learn at masters. And I actually got inspired by you in the first place. Like I'm teaching a little bit of old architectures as well. Like
Nice.
I don't know, hop-field networks and stuff, autoencoders. But I thought, people actually miss out on this, and these are actually used from time to time, and people actually need this. There's not so much content out there. So I thought, yeah, I can do it. And I've been doing it for the last year.
Nice.
Like you are a great source of inspiration, by the way. I just wanted to say that. I'm still pinching myself, talking to you.
No, this is great. I mean, there is I think still a lot of space for this type of content. In whatever way, it's really cool.
But I mainly follow you for the ML news. I'm just saying because the tweets are very good.
Yeah, I have to be careful not to be like too cynical all the time. It's easy to be cynical, right? But yeah.
Yeah, it also, people actually like it a lot, seeing someone bashed or... I mean, you're not doing it personal, and people take it personal from time to time, and I realized that later. But you are actually not doing this personal most of the time, so yeah.
Yeah, no. I try to criticize ideas or papers as such.
Or work. So yeah, thanks a lot for coming. People have written a bunch of other good stuff, like they're congratulating you on 100K.
Thank you.
Thank you so much. See ya.
Thank you.